All right, this topic is on matrices dimensions and scalar multiplication. So a matrix is a mathematical way to organize data without having labels. And so how we set them up is with columns or rows. And so this is an example of what a matrix looks like. So we count the number of columns and rows. So we have a matrix dimension listed by the number of rows by the number of columns. So if we look at this example here, this is 1 row, 2 rows, 3 rows, and then column 1, column 2, column 3. So we call this a 3 by 3 matrix. Example 1. What could the data values in the matrix represent? So we have 6 data values in this matrix. So matrix, plural matrices, is a rectangular array of values that might be used to help organize information. So for example, if the columns of this matrix might represent sizes, so you might have something like small, medium, and large, where the rows are going to represent the clothing sizes, and then the shirt sizes being shirts and sweaters. So that could represent 4 large sweaters. So then we'd set up the matrices as below as such. I'm just going to highlight this here. So we use a capital letter to refer to the entire matrix. So matrix A would equal this matrix 5, 3, 0, 2, 1, and 4, those 6 elements. The dimensions, there are 1, 2, so 2 rows, and then 1, 2, 3 columns. So we call this a 2 by 3 matrix. Then we get into specific row and column elements. So a specific element can be referred to using subscripts to indicate the row and column where the element is located. And we call this row I and column J. So if we have A, I, J, you look at the row and then the column number. So we'll look at that in an example below. So example 2 says, using packaging data for costs of packages given. So the cost of a 4-inch cubic box, and there is plastic and paper, and then there is the total cost, the cost per square inch, and the cost per square inch cubed. And we want to set up a matrix C and label that matrix C. So we're going to go ahead and enter in our 6 data points. So the first column will be our plastic. Data points. And then our second column will be our paper data points. And it's asking us in part B, what are the dimensions of this matrix C? So this is, again, our matrix is the number of rows. So there are row 1, row 2, and row 3. So 3 rows by the number of columns. So column 1 and column 2. So 2 columns. So this is a 3 by 2 matrix. The next thing it asks for is what is the entry of C12 and what does it represent? So C12 and what does it represent? So the first number is going to represent the row number. And the second number is going to represent the column. So we go to row 1 and then column 2 in the matrix C. So we're going to row 1, column 2, and I'm just going to highlight that entry point. So that's the element 0.072. And what does that represent? And it's kind of getting messy here. Well, that represents the total cost of a 4-inch paper box. The total cost of a 4-inch paper box. All right, example 3. What are the values of the variables in the matrix equation? So now we have a matrix C on either side of this equation. So the data points will line up. So when I have matrix in the upper left, it's going to correspond with the matrix on the right side of the equation in the upper left. So those two elements are going to be equal. Then again, in the upper right, those two equal each other. So when we look at that variable y, what does y equal? Well, that's going to equal 0. I'm going to go down to the bottom. The bottom two are matching elements. So then 2x equals 14. And then what we do in this equation, we have to solve it. So we solve it like we'd solve any linear equation. We'd solve by undoing. So we divide both sides by 2, and we get x equals 7. And that last point there, again, these elements are both matching. They're both just 10. So it asks us what are the values for which the variables are. Y equals 0 and x equals 7. Okay, example 4. So we have a missing value here. So we go to its corresponding element, which is the -5, and we set that equation equal. So 2y minus 1 and its matching element -5. And then we just solve that equation. So we do our inverse operations. We add 1 to both sides. We simplify the right side, and we get -4. Then we do our inverse operations again. We divide both sides by 2, and then we simplify. So our first value in the equation is y equals -2. Now we have another missing variable for x, and we do our corresponding element of 16. So we're going to set up an equation. So we have 3x plus 1 equals 16. Now we're going to solve that for x. So we do our inverse operations. We solve this linear equation. So we're going to subtract 1 from both sides. Simplify the right side, and we get 15. Then we're going to divide both sides by 3 and then simplify. So x equals 5. The next thing is scalar multiplication. Scalar multiplication is when each element in a matrix can be multiplied by a scalar. Scalar does not change the dimensions of a matrix. It's not going to change the rows and the number of columns. So when we do scalar multiplication, we're thinking of it as like the distributive property. So here's an example. We have a scalar multiplier of 3. What you do is you're essentially distributing that 3 into all of the elements inside of the matrix. So you're seeing that in the second step here. And then you simplify it. All right, here's an example of that. Cool Threads, a clothing store, uses a matrix C to represent the prices of women's clothes. The columns represent vintage, casual, and distressed, where the rows represents jeans and jackets. There's going to be sales tax of 5% on these items. How can you use a matrix operation to find the amount of sales tax on each item? So I'm just going to go ahead and just label what those rows and columns represent again. So again, in the columns, they represent vintage, casual, and distressed. Then the rows represent jeans and jackets. And what we're going to do is add sales tax. So we're going to be increasing the price of all of those clothing items. So we have to multiply each element by 5%. You can figure out what is our sales tax. So that's going to be our scalar multiple. So now we're going to go ahead and create a new matrix. So S equals, and then our scalar is going to be 0.05. And now our C comes down from here. So here's our matrix. So we put in 320, 210, 160, 240, 110, 65. And what we essentially do is we multiply each of those numbers by 0.05. So you take 320 times 0.05. Actually, I think we can probably just do these with our calculator is fine. Just going to erase that. You can pause if you'd like to and just take your calculator and multiply those. And when we're done, we're going to get 16, 1050, 8, 12, 550, and 325. So what we found is the sales tax for each of the items at the clothing store. So if we wanted to talk about what each of these items were, let's say this one right here, this one represents $3.25 for a distressed jean jacket or jacket.